Welcome. It is such an exciting time to be here to come to tell you all about the amazing devices that we're shipping with Windows on ARM. I bet many of you have read, watched, or heard about our announcements yesterday. And it is amazing the devices that we've been able to achieve on the latest silicon. Before we get started, let me tell you about myself. My name is Yvette Carreras, and I'm a principal software engineer at Microsoft. Last year, I came here and told you all about Windows on ARM. I've continued the work on Windows on ARM, specifically around debugging and scaling for the Windows platform. Now, today, I'm here to tell you all about Copilot+, or Copilot+ PCs. If you watched yesterday, you can really see the immense effort that we've put into Copilot+ PCs and Windows to make it a new, innovative era for Windows. And Windows on ARM is leading on this category of PCs. Today, we'll go over the details of the Copilot+ PCs for ARM specifically. We'll also tell you all about the additional improvements and features we're bringing for the developer workflow. We'll see what the app momentum looks like, as well as improvements on gaming. I mean, did you all see the announcement yesterday? These devices are the result of a strong partnership across Qualcomm, Microsoft, and our OEMs to best integrate the silicon and Windows 11 and bring incredible experiences to our customers. Truly monumental. Now, some of you are here because you watched yesterday, and maybe you're getting a little ARM curious. But I bet many of you have been working on Windows on ARM for some time, building libraries, applications, and frameworks, just like I have. It is stunning, the progress we've made. If you watched, we have so many OEMs delivering incredible devices, so sleek. We no longer need to compromise on device form factors or performance, and most importantly, on the experiences we have on these devices. All of it without sacrificing the efficiency, the performance per watt that ARM brings to these devices. These two aspects alone are quite stunning, and they make for an impressive device. But that's not just it. We also have the industry's most powerful NPU for all of you to build incredible AI experiences. It all starts with a silicon. The industry's most powerful NPU can deliver 45 trillion operations per second, all for you, all faster and 100 times more efficient than any other compute on this class. Quite impressive. I mean, think about the experiences that we're shipping with the latest Windows 11. Think about Recall, for example. It has multiple models running in the NPU constantly, inferring and building that semantic index that Pavan talked about yesterday, so that we have amazing experiences for the customers. All of it without taxing the CPU and the NPU, and without leaving the data, never leaves the device, which is critical for our privacy. And no additional cost to the application or the end user, because you're using the hardware right there on the device. Now, there's other cool stuff too. We have 12 cores running at up to 3.8 gigahertz all across. We have a great GPU that supports DirectX 12. And we have blazing fast memory so that you can enable fast and smooth experiences. On top of that impressive hardware, we're bringing the best Windows on ARM yet, the fastest Windows 11 for ARM. This is thanks to our partnership with ARM on the design of Armv8, as we've now integrated our experience of years building and optimizing for Windows into the hardware. We've then taken our compiler and leveraged all of those improvements so that our runtimes, Windows kernel, and system components, as well as all of your applications, can really maximize the use of the CPU. Not just that, we're also using the profiler guided optimizations with sampling from a wide range of workloads and applications so that customers get the best experience on what they really care about. Now, emulation continues to be a critical aspect on this platform, enabling many scenarios just like that. We are happy to say, with the latest Windows 11 update, we have a new emulator, Prism, which can attain 2 times the speed up on all scenarios across compared to previous hardware and the previous OS. We also do faster on benchmarks, and not just benchmarks. We are able to do really, really well with complex applications like Baldur's Gate 3, a heavyweight game that can run emulated at 25 to 35 frames per second. Now, I think it's time I stop talking. I want you all to hear from Affinity. They got an early prototype of these devices, and they've been building for them. So let's see what they have to say.
Hi, I'm Ash Hewson. I'm the CEO of Affinity. For those of you who might not be aware, we produce high-end professional creative applications. And I've got to say, we've been blown away with the level of performance we can achieve with these latest Snapdragon X Elite devices. And of course, that all comes down to that silicon, having a high-powered CPU with a high-powered GPU with unified memory, of course, is absolutely perfect for our type of applications. And it means that we can actually now achieve speeds which were previously only possible with a big desktop PC, but now in a package that's thin, small, light, with all-day battery life. And we know that our customers are going to receive that in an overwhelmingly positive way. I've also got to say that we're really excited to work with the NPU that's available on these chips. We are actively developing a number of machine learning features for Affinity at the moment, and it's really important to us to keep as many of those running on device as we possibly can. And again, that's really only made possible with the high-powered NPUs that's available on these latest chips. I think the final thing that I want to say is that we found it actually pretty easy, to port our apps from x64 to be native ARM. We absolutely did some specific performance optimizations. I'm delighted to say that the entire Affinity suite is going to be shipping with native ARM support this week.
Wow, all right, so I hope many of you try Affinity later this week as it comes available. Next, let's talk about that powerful NPU. The latest Windows 11 update fully integrates the NPU into the system. Over here, you can see a picture. I took this on my Surface laptop, and I was running the camera app using Windows Studio Effects on, and then I was working on my presentation, so you can probably notice. So I searched for Surface laptop images, and that's the spikes that you can see. So now you can see how applications are utilizing the resources of the NPU as you would expect for the CPU or the GPU. Not just that, we've taken years of learnings of integrating and bringing GPU on the Windows ecosystem, and we're applying it to how we're approaching the NPU. For example, we're building the MCDM framework, the Microsoft Compute Driver model, so that you can best run AI workloads on the device. We have great threat prioritization and task scheduling across the device. We're also shipping Windows-optimized AI models for you to easily integrate into your applications. For example, Phi Silica, a great text summarization and text completion model, is available for you to use by simply calling into APIs. We're shipping another model that is great at taking text from images and extracting them for your own scenarios. Now, you may be wondering, well, I want to build my own models. So for that, we encourage you to develop applications using DirectML and the ONNX runtime to target the NPU. There are other talks at Build this year that are actually going to dive into the tools, the libraries, and how to get started on this. So go and make sure to check them out. Now, Camo is another great partner we have on the Windows on ARM platform. And they also got an early prototype of this device and have great things to say about it. Let's hear them out.
Hi, I'm Aidan from Recubate. Our product, Camo Studio, helps anyone achieve incredible video for meetings, streams, and content creation, handing them precise control and a range of powerful effects to perfect their image with any camera that connects to their computer. Our models power AI effects that separate subjects from their backgrounds, allowing them to add adjustable depth, privacy blur, and physical or virtual chroma keys. It follows their hand movements and gestures, putting AR at their fingertips, and dynamically tracks and frames their faces, freeing them to move while they remain centered and sized in shot. Snapdragon X Elite is capable enough that we're leaning on it to power a number of generative AI features that will be coming to Camo later this year. As a developer, the obvious question is, well, okay, but how easy was the port? We had the core Camo Studio app running natively on ARM within a day on our dev kit, and our drivers just needed a recompile. I was surprised by that, but using native libraries and Windows APIs really paid off to make the most of the hardware. We found that most packages we needed were available for ARM with a single click, and emulation of x64 works very well. I'd recommend developing for ARM-powered Windows devices, and I'm glad we did.
Now, very quickly, I want to touch on one critical aspect of this devices, which is power and thermals. Truly, the ARM architecture continues to deliver unmatched performance per watt to devices, enabling all-day battery life and thin and quiet designs, which are not just sleek, but also critical to folks like musicians and content creators on their work and life, I guess. Yeah. So let's hear it out from Algorithm on how they're using their apps to enable content creation.
Hi, this is Frederick, CTO at Algorithm. We make DJ Pro, the award-winning DJ app. It allows you to mix your favorite music right on your laptop with professional-grade tools and an intuitive interface.
Hi, I'm Omar, lead machine learning engineer at Algorithm. DJ Pro is powered by a number of sophisticated machine learning models that run on-device, from our audio analysis engine to Neural Mix, a performance tool capable of separating music into its original components, such as vocals, drums, and other instruments. Using the NPU to run these machine learning models can offer more than a 5x speedup and allows us to run even our largest models on device.
Having used ARM-based Windows devices, you don't want to go back. With long battery life, great portability, and impressive performance, we can't wait to bring this to Windows users on ARM devices later this year.
All right, now I want us to have some fun, but I'm no gamer, so Marcus Perryman here is going to help me out by playing this game for me. So this is Borderlands 3, and it is running on a special device we'll tell you all about in a minute, and it's running emulated. Check out the frames per second. It also has auto super resolution turned on, which is a feature we'll cover on later. Hi, Marcus. You managed not to die. Thank you. Oh, no, you did die. So, to tell you more about this incredible device Marcus has over here, I'm going to give it up to him to continue.
Just give me 1 second to shut the game down. Thank you, Yvette. OK. Thank you, Yvette. Hello, everyone. My name is Marcus Perryman. I'm a principal engineer in the Windows division. And my focus is on the Windows on ARM ecosystem and how we can empower every Windows developer to create exceptional customer experiences and to make that possible without compromise of the silicon upon which Windows is running. Let me start with the device that we were just using. Developers like you need developer devices that can support the everyday workflow that you need and keep the dev loop tight of compiling, deploying, testing, and debugging. And this is it. So this morning, Qualcomm announced the Snapdragon Dev Kit. And that's specifically designed to support developers, those specific requirements. The Snapdragon Dev Kit extends the intent of the Windows Dev Kit 2023, providing a small desktop form factor that actually packs a serious punch, 32 gigs of very fast memory, lots of ports for your different devices, and support for multiple high-res displays. All of this is powered by a lightning-fast Snapdragon X Elite system on chip. And that chip has been optimized specifically for developers in this edition to max out the capability that we have. It also addresses in this box two of the common feedback. One, we have a network port on the back, an RJ45, which supports remote kernel debugging. And the second thing is we have a full-size HDMI port for better flexibility of displays. And I have to say, this device absolutely rocks. Pre-order is available this morning at that link. Qualcomm announced a price of $899 US, and they said it's available worldwide delivery. Before I show you some demos on that device, let's stop and consider the Windows on ARM ecosystem. To build exceptional experiences, developers need the right tools available at their fingertips. I showed a big shift in Windows on ARM support last year's talk for each of these three areas: in the development, in the deployment, and in the dependencies. And the momentum that we saw last year has not stopped. It has continued, in fact, accelerated. And the pace is increasing with many more industry standard tools and developer middleware coming to support Windows on ARM natively. I want to call out just a few. There's too many to go through them all. Let me pick out, first of all, GNU GCC. It's the last piece of the jigsaw puzzle of C support for Windows on ARM. And with the patches that were merged just recently, there is support for Windows on ARM in the GCC compiler that is expected to ship in version 15 later this year. Let me call out Qt, a middleware tool that people use to bring their C code across multiple platforms. Very useful. And the work that they had done previously to bring experimental support for Windows on ARM is now maturing to the point where we have LTS coming with version 6.8, long-term support for the product. So we can put that now into production code with no worries. And the last one I'll call out from this list is the release of the ARM performance libraries specifically for Windows. Now, these libraries are a set of maths operations, common maths operations that are optimized to make the best use of the silicon instruction set we have in Windows. And what we're seeing with this type of product coming to Windows is that developers are able to move from just enablement of Windows on ARM to getting it absolutely to the max in their code and start to differentiate the experience beyond equality. Okay, let's switch and take a look at some code. So this machine is the Snapdragon Dev Kit on here, and I've synced another of those products that were on the list, which is Blender. So Blender is now available with nightly builds for Windows on ARM. And I mean, every minute of the build time of Blender is exciting. But I didn't want to make you sit here for 18 minutes to watch me complete that. So building from source for Windows on ARM on this device took me 18 minutes. Now, how do I give you a reference point for that? Well, if I were to do that on a previous machine, the Windows Dev Kit 2023, it's about half the time to build it on this machine, which is pretty impressive. What's even more impressive is when we actually run Blender itself. So I'm going to do that and just render a scene. So we'll open a recent one. Here I've got Classroom. It's a relatively simple scene, so it renders pretty quickly. I'll go ahead and render that on the CPU on this machine. And we'll pick up just to show you what's going on behind the scenes. Blender is very efficient at using everything that you've got on the machine. All 12 cores are maxed out while Blender is rendering those ray traces for that image. You can see, though, the base speed for this CPU is 3.8. It has a dual-core burst speed of 4.3 gigahertz in this particular SoC, faster than the fastest one in the retail devices. It's got those 12 logical processors. You've got 8 of which are high-powered cores, 4 of which are for running sort of background tasks and things. And I can see my blend is complete. And we can see from that a beautiful scene rendered through Blender. Okay, fairly simple. Let's maybe switch to a slightly more complex scene, which I have here. So this is the Blender 3 standard scene from Blender. And in here, I can see that GPU accelerating my design experience really smoothly inside the Blender tool itself. Pretty useful. But when I actually render the scene, as I said, it's a far more complex scene. I did it before, again, wasn't going to make you wait the 8 minutes to do this. But that 8 minutes, again, in context, it would take 50 minutes on a previous machine. So you can see the step up in the hardware and the development we've done. Right, let's switch to some code. A little sample I wrote to highlight a couple of points. Little piece of C++ code. It's got basically a geometry of 40,000 matrices, and all I'm doing is rotating it and doing some simple vector math here in C to demonstrate how this works, how we can use the CPU. So if I run that, get a nice pretty diagram. But the key thing to look at the transforms per second. I'm getting 33,000 operations on those matrix points per second. What I can do here is switch to use that optimized performance library, and it should, okay, my machine is not behaving. It should jump to about 58,000. So it jumps about to almost 40% more. It might come up, there we go, it's going up now. Okay, 40 is all it's going to get today. That's a demo machine for you, isn't it? But the point is, what we're seeing here is when we use sort of like standard C++ copy across to the device, we get great performance on the Snapdragon X Elite. But what we now have with things like APL is we can go and optimize those and get the absolute maximum out of the device. Okay, that's enough from me. Let me switch back to slides, and I will invite my colleague, Jamshed, who's going to take us through some more of the developer tools. Thanks.
Thanks, Marcus. Hi, I'm Jamshed. I'm a principal TPM in the developer division, and it's my pleasure to be here today. I focus on ensuring we have best-in-class tools for developers that want to build apps on ARM for ARM. Today, I'm going to go over some of the work we've been doing to increase developer productivity and dive a bit deeper into how you can build highly performant code on ARM. .NET, as you know, has the AnyCPU target architecture. AnyCPU means that when the program is run, the .NET runtime will look at the architecture of the OS and figure out what application launch architecture should be. Let's take a quick look at this in action. As I was preparing for this session and needed to make some videos of my demos, I fired up Clipchamp. Clipchamp, as you know, is a .NET application. I have the source open here. I've also fired up Clipchamp. And when I look at Task Manager, I see it's running as x64. Like I said, Clipchamp is a .NET application, and it's built as AnyCPU. So what's going on here? I would have expected, using any CPU, this application would have fired up as an ARM64 application on an ARM device. That didn't happen. Why? What's happening is, for compatibility reasons, any CPU apps don't automatically roll over to ARM64 on an ARM device. Now, we could have automatically launched it as an ARM64 app, and any CPU apps will run just fine, but if the app were to have a dependency, a native dependency that is satisfied on x64 but not ARM64, it will fail to launch. So to be safe, for greater compatibility, it launched as x64. Now that's disappointing, because I happen to know Clipchamp would have launched as ARM64 just fine. So how do I tell the OS that when I said any CPU, I really meant it? We have made it really easy for you to make that choice. We have here a new property, supported architectures, and all I'm going to do is add ARM64 to this. Now, I'm not going to wait for a build. I've already pre-built this. I'm going to just install the version that I have pre-built. Should be just a second. It will finish. It will finish. I'll give 10 more seconds. It's killed the app. The running one is already killed. Yeah, there, it fired. Yeah. So it's firing up now. And as it fires up, we can look at Clipchamp. That's ARM64. So all I did here really was add ARM64 to supported architectures. Supported architectures, this property is now available in the latest Windows Insider builds, along with Clipchamp running ARM64 native. So let's talk about containers. Containers are a pretty popular deployment target for all the reasons you see up here. A lot of developers told us they missed the ability to deploy their apps to Docker on ARM. As the platform gains traction, the demand for Docker compatibility has grown. The ability to containerize applications seamlessly on ARM-based Windows devices will greatly improve developer productivity. We have a special guest here with us today. It's my pleasure to introduce Justin Cormack, CTO of Docker.
Thanks for having me. Well, as you might have seen in the sneak preview, if you saw the screen before, we are pleased to announce today that Docker Desktop is now fully available for Windows on ARM. And you might have actually seen it running if you look carefully, and even seen the ARM64 on the architectures if you're looking just under Clipchamp. So we're really excited about that. It's been something that so many people have asked us for, and it means that you can run Docker Desktop on any device you like, any laptop, as well as, of course, on DevBox on Azure as well.
So how does Docker Desktop simplify the development process across different architectures?
Well, Docker lets you build many different architectures of containers. You can build Windows containers, Linux containers, ARM containers, or x86 containers, and you can cross-build them. And so you can build locally on any architecture, or you can deploy to any architecture in the cloud, which is really flexible.
And what does that do for developer productivity?
Well, developers love their laptops, and everyone's really excited about these new Copilot Plus PCs because they've got such long battery life, they're such great developer experience, they've got all the AI tools you've got, and all the opportunities to build stuff. So they really give people an opportunity to have the best laptops. Developers are very, very, they're very demanding users of laptops and of these developer machines. And so having Docker Desktop enables them to have the best developer experience, build containerized applications on the nicest hardware.
Thank you. What's your call to action for developers that want to start using Docker Desktop on Windows and ARM device?
Windows and ARM Docker Desktop is available in the 4.31 release, so download that and give it a go. And as you can see, it's already running on your machine.
Thank you, Justin. I'm sure you've made a lot of developers very happy today.
So many people have been asking us for this for such a long time.
So let's take a look at this in action. So for this demo, I'm going to use the eShop sample. This is a full-fledged reference application built using .NET Aspire. And it utilizes a cloud-native microservice architecture with a great-looking web front end. The app gets deployed across several containers. Let's run this app. So here I have already set the app host as a startup project. This launches the orchestrator, which creates the containers. If I take a look at Docker Desktop, I'm going to see all the images that were created and the containers here. If I go to the dashboard, I see all the containers, the processes. Let me fire up the web app. I will try that one more time. Yep, should be fine now. There's a timing issue. Beautiful front end. We're at the home page here. We see a product catalog. It's built-in using Blazor Web Components, all running inside containers. With Docker Desktop running natively, you saw how seamless it was for me to deploy the app to an ARM device, just like I would an x64 device. So I can now spend more time working on building my app and less time worrying about platform compatibility and differences. Now, when I look at this app, I see pricing here has 3 decimal places, probably a bit more than what we need here. So I'm going to make a quick change. And I will just fix the currency format here and relaunch it. And start the web app again. And looks like that's fixed. Since I've made a change, I don't want to lose it. I'm going to just commit this change. And I'll push it to the server. I'm building and testing this on an ARM device today. So I'm happy to share that GitHub-hosted runners for Windows and ARM are in private beta right now, and general availability expected later this summer. I'm looking at the workflow queue here. I see this job is already queued up. It's already running. I'm going to just open it up. Look at the setup for the job. And I look at what the image is, and you can see it's a Windows and ARM device for this runner. Yeah. Earlier, you heard Marcus talk about ARM performance libraries and how you can have highly optimized code that runs fast on ARM devices. Now, I want to show you a bit of the work we've done in the .NET runtime, leveraging the ARM architecture. ARM processors have a 17th register, the CPSR, current program status register. This register keeps track of things like conditional states, endianness, flags, processor mode, etc. The last 4 bits help us write code that leverages conditional operations. So how are conditional operations useful? Let's take a look at this in action. On the left side here, we have a simple method max, which takes 2 integers, compares the 2, and returns the greater of the 2. The code gen for that in .NET 7 let's look at the assembly code that was generated. We have a simple compare, then we have a jump, and then the greater of the two values is returned. There's already a jump, so it's suboptimal since branching is expensive. And this is about 10 bytes of opcode, so a certain number of clock cycles. Now let's look at .NET 8. In .NET 8, we have a compare again. Then we have a conditional move, and that looks at the flags set by the status of the previous compare operation. And based on the results, it will move or not. And that's 8 bytes of opcode, so it's already smaller, faster. How much faster? Let's take a look. So here I have a bit of code that's very similar to the max method you just saw. We generate a random number between 0 and 1, then we compare it to 0.5, just so that we can have conditional branching. And then we call this getOptions method, just so there is a little meat to it and we can get some meaningful results. I've wrapped the code that I want to benchmark with benchmark.net. It's an OSS library under MIT. To save time, I've already run the benchmark, so I can just show you the results. Take a look. With .NET 7, 6.3 nanoseconds. .NET 8, exact same code, 1 nanosecond. 83% improvement. Wouldn't you all like to see the same kinds of gains for your code? With that, I'd like to hand it back to Yvette.
Well, thank you, Jamshed and Marcus, for all those amazing demos. As you can see, we've been doing incredibly well on Windows on ARM this year. We have so many wins. These are just, well, you're not seeing what I'm showing you. All right, there we go. Oh, no. These are just some of those that we wanted to highlight for you. But there is a lot more. In this picture that I'm super happy to share with you, you can see applications across multiple sections like entertainment, social media, frameworks, IT management, and they're all native on ARM. We've been fortunate to work with hundreds of developers just like you across many companies to bring these applications to ARM. Now, thanks to emulation, we can add even more to this picture, completing a set of apps and frameworks and tools that we all need to be effective. Now, I want to highlight browsers because they are critical and really so important to our everyday work and productivity. All of these browsers, all 7 of them, which are the most used browsers on Windows, are native on ARM. Later this summer, when you all go and pick up a Snapdragon X Elite-based device, you'll be able to install and use these browsers native. Now, let's talk about gaming a little bit. Earlier, when Marcus was playing Borderlands 3, I mentioned Auto Super Resolution. Auto Super Resolution is a Windows 11 feature that comes for the Snapdragon X Elite-based devices that enables you to play games in a much, much better frame rate. Auto Super Resolution, and by the way, this picture, you can see the comparison between a natively rendered app at 1040p versus a game rendered with Auto Super Resolution. The visuals are pretty much identical, but look at the frame rate. Auto Super Resolution is able to beautifully balance the frame rates per second and stunning visuals for the best gamer experience. I want to show you another example so you can see most games render at a lower resolution so that they have an okay frame rate. With Auto Super Resolution, you get much better visuals, as you can see in these examples. Much, much crispier, more details, just stunning. In terms of game compatibility, I'm happy to say that WorksOnWindowsOnARM.com is live now. This is a website that is the result of the collaboration between Linaro and Qualcomm to bring to you the best working games on ARM, categorize them, and enable you to add your own data, your own experiences, and share with the community. We also have progress on anti-cheat. BattlEye now supports Windows on ARM, which enables and unblocks popular multiplayer AAA titles like Rainbow Six Siege. And finally, Unity. Last year, I came here and I announced to all of you the support of Unity for the native runtime engine. This year, we continue our partnership, and I'm happy to say that Unity 6 Preview now supports the editor as a native application on ARM. Not just that, it's also boosted rendering performance for DirectX 12 with backend improvements, and simplified multiplayer game creation with Unity Cloud Services integration, Multiplayer Center, and multiplayer mode. Now, I want to show you all what this looks like on one of the Snapdragon-based devices. So I'm going to pull it up here. Oh. We got a complicated setup, folks. All right, this is the Unity editor running on my Surface laptop. Now, this is a sample you can download yourself and try out, but I really like to go to the Oasis scene. It's going to load it up. Now, I'm going to go ahead and check out how my scene is coming along. So I'm going to go ahead and walk around and show you how pretty this all looks. Can you see the sun, what is it called, the reflection, the little spike there? The flare, thank you. It is beautiful. And it performs as you would expect for a native application in Windows on ARM. All right. Now, so much content, so many great things for the platform this year. The devices are just incredible. Try them out. We have a few upstairs that you can see. We also have the Windows on booth that you can come and talk to all of us for any questions you may have. Now, as I was preparing for today, I was thinking about what really do I want you all to walk away with. And there's a single takeaway today, which is I want you all to bring your high ambition experiences to the Windows platform. So come on, go and innovate for your customers. All right, so we have 3 minutes, and we're going to go ahead and take a few questions from Pubble. Marcus and Jamshed, if you can come ahead and join me as well. Mark will read.
You have a question, Mark?
He needs the mic.
Yeah, go ahead.
Yes, thanks everyone. We've had a lot of questions in Pubble. I've been trying to keep up. I apologize for the ones who I haven't answered. Quick question for you, Marcus. The dev kit, is the 512 gigabyte storage expandable? Is that something people can mess with?
So we actually have somebody from Qualcomm in the room.
I've been following that question online. I don't have an answer to that right now.
OK, let me just repeat for everybody. So Qualcomm, the device is very new to us to look at right now, and we're working through some of those things. Qualcomm is saying they don't have answers just yet for that. I can tell you though that the thermal capacity of the device is pretty high. It's 80 watts capability. So with the device, with a chip in there and everything, it could be challenging, but we'll wait for Qualcomm to confirm. Another one, Mark?
Does Docker Desktop on ARM run via WSL or via Hyper-V?
Both. WSL. WSL.
Thank you. Is DirectML supported for Windows on ARM?
So that's an interesting question. Do you want to take that, Fred, or somebody else?
Yes, it is supported.
Yes, it is supported. There you go.
That was an easy one.
Yeah.
Do we have anything we can share about eGPUs today?
About eGP.
eGPUs, sorry, external GPUs.
I still didn't catch that.
External GPUs. We do not have
external
anything.
GPUs, right. Again, the Qualcomm team have nothing to announce today about support for discrete GPUs.
And does Docker require build 26100, or can it work on earlier versions of Windows?
I'm using 26080. I know it works. I don't know if that's the officially supported one. The release that's shipped this week should list system requirements. So I'm sure it's on the public page.
Okay, we've got time for one more. What's the last question?
That's pressure. So Jamshed, you showed off the setting for any CPU apps to have them run.
Supported architectures, yes.
Supported architectures. Is there a similar setting for ClickOnce?
Tell me what you mean.
ClickOnce apps.
What about it?
Is there a similar setting to have those run as ARM64?
I do not know the answer to that. I will circle back.
Okay, right. That's all the time we have, folks.
All right. Thank you all.
Thanks a lot.